Hello everyone, Darren from Dratech Australia and New Zealand. A large unmanaged network environment can result in poor network performance as well as reduced productivity due to network congestion and dropouts to services. It can also pose a security risk if critical servers are easily accessible by anyone within the network. In today's webinar, I'll discuss how using VLANs can greatly improve your network performance as well as help to provide security for critical devices on the network. I'll start by first looking at what VLANs are and why we need to use them. We'll also look at the topics listed in the outline shown here, where we'll look at the types of VLANs and how to create routes between them when needed. Then we'll look at some typical applications and how to configure VLANs in Dratech Vigor routers. Let's start by looking at what a VLAN is and why we need to use it. Here we have a definition of a VLAN which says a virtual local area network, or VLAN, is a logical group of workstations, servers and network devices that appear to be on the same LAN despite their geographical dispersion. So in other words, a VLAN is a group of devices that are physically on the same LAN but separated by using information in the Ethernet packet, and they don't necessarily have to be all together in one place. The VLAN information is in the layer 2 header of an Ethernet data packet as shown in the diagram down the bottom here. It's 12 bits of data between the type and source MAC address sections of the Ethernet packet. Using VLANs allows you to segregate your network and prevent devices in one part of the network from getting access to other parts in the network and vice versa. VLANs allow you to segment your network by function or application. Unicast, broadcast and multicast packets are forwarded to ports in the same VLAN. This enhances the network performance since broadcasts and multicasts aren't sent to other parts of the network. VLANs also ease network configuration by logically connecting devices without physically relocating them. We have a typical application of VLANs in this diagram. We have 4 local area networks, administration, sales department, support department and the warehouse. The devices in each of these LANs could be in different locations within the company and are segregated from each other, but are logically part of the same network using the same cables, switches, router and internet connection. In a larger network, you often have IP cameras, IP phones and so on, in addition to the PC data network. In many cases, if all these devices are installed in a flat network, that is everything on the same subnet, you'll often see network congestion resulting in slow network response times as well as poor phone call quality. The solution is to separate each of these services by using VLANs. One of the benefits of using VLANs is that it increases the number of broadcast domains. This will reduce network congestion and improve network performance. In addition, having smaller broadcast domains also helps to improve network security. For example, if a device in one VLAN sends a broadcast Ethernet frame, all devices in the VLAN receive the frame, but devices in other VLANs do not. So segmentation improves network security, performance and administration required. VLANs can also be used to create logical groups, and communication between required subnets can be enabled. Firewall rules can then also be used to control data flow between networks where routing has been enabled. This will increase network security and minimize external threats. Imagine an attacker from outside gaining access to one VLAN. They'll be contained to that network by the boundaries and controls in place to prevent them getting access to another network. Some points to consider in addition to using VLANs to secure your network. Physical security. You can ensure that unauthorized users cannot physically access your network. You can perform auditing and mapping to identify potential vulnerabilities. You can keep your network up to date with the latest patches and updates. Consider MAC address filtering to restrict access to your network, and use 802.1x for authentication to ensure that only authorized users can access your network. Also, VLANs aren't restricted to just one switch. They can extend across multiple switches. This will increase flexibility to the network. And grouping is logical here, not physical. Let's say within a building we have the sales department on the first floor, but one of the sales staff members is working on the second floor and needs access to resources on the sales department network. Not a problem. No matter where their PC is placed within the building, it can still be part of the sales VLAN. VLANs also help to make network administration much easier. By logically grouping users into the same virtual networks, you make it easy to set up and control policies at a group level. When users physically move workstations, you can keep them on the same network with different equipment. Or if someone changes teams but not workstations, they can easily be given access to whatever new VLANs they need. Troubleshooting network problems can be simpler and faster when different user groups are isolated from one another. If you know that complaints are only coming from a certain subset of users, you'll be able to narrow down and resolve the issue quickly. VLANs can also improve quality of service by managing traffic more efficiently so that end users experience better performance. There will be less latency problems on the network and improved reliability for critical applications. VLANs can also be used to prioritize traffic. This will make sure data keeps flowing on critical applications even when lower priority traffic congestion like web browsing spikes. Now that we know what VLANs are and why we need to use them, let's look at the different types of VLANs. The two main types are port-based VLANs and tag-based VLANs. The first one we'll look at is port-based VLANs. As shown here, the VLANs are assigned to the LAN ports on the router, so any devices plugged into one of these ports will be a part of that VLAN. We have three VLANs shown here, VLAN 0 for sales and VLAN 1 for admin, and a guest Wi-Fi VLAN. So for example, anything plugged into ports 4, 5 or 6 will become part of the admin VLAN. Each of these workgroups will be isolated from each other but can still access the same internet connection. The next type of VLAN is 802.1q tag-based VLANs. In this case, the VLANs aren't tied to any particular port on the router. In the example shown here, we have three different workgroups represented by different colours connected to a switch, and the switch is joined to the router with a single cable. This is called a VLAN trunk connection. So if the VLANs aren't tied to any particular ports on the router, then how do we do it? We use VLAN IDs or tags in the router configuration, which the switch then picks up and assigns to its ports. The VLAN ID is limited by 12 bits or 2 to the power of 12, which gives a maximum number of 4096. However, the actual number of VLANs that can be configured will be limited by the router or switch model and would usually be between 2 and 50 VLANs. As mentioned earlier, the VLAN tag is in the data packet header and is used to identify which VLAN it belongs to. Another parameter in the VLAN tag is the 802.1p setting. This is used to specify the priority level for the data packets and ranges from 0 for best effort to 7 being the highest level. If you want to allow communication between each VLAN, then inter-LAN routing has to be enabled between the VLANs. So back to our original network example, we want to allow communication between the administration workgroup and the sales department, but not any of the others. So all we need to do is enable routing between these two LANs, but leave it disabled between all other LANs. I'll show you how to do that in a moment. In addition, if you want to add extra security between routed VLANs so there's not just blanket access between them, you can use firewall rules to control access to certain devices. For example, you may only want the PCs within the IP address range of 192.168.1.100 to 110 to be permitted to access devices in the other VLAN, which is in the 192.168.50.x subnet. Anything outside of 192.168.100 to 110 will not get access. To do that, in the firewall filter rule shown here, we use the invert option shown by the exclamation mark for source IP, so any devices outside this range are blocked from accessing the other VLAN. For this to work, you'll also need to use strict bind IP to MAC to lock in the PCs to fixed IP addresses and prevent the users from changing their IP address to bypass the firewall settings. Before we get into the configuration options, including how to enable inter-LAN routing, let's take a look at some typical scenarios where VLANs can be advantageous. Let's assume that a company wants to separate the employees' Wi-Fi network and guest Wi-Fi network so it can restrict network access by guest users. We want guest users to be able to access the internet, but we don't want them accessing other LAN resources such as the server, printer, internal portals, and so on. So two VLANs can be defined here to accomplish this, VLAN 1 and VLAN 2. The LAN subnet for VLAN 1 can be set to 192.168.1.0 and the subnet for VLAN 2 can be set to 10.0.0.0. And of course in this case we want to keep inter-LAN routing disabled. Another scenario is where four companies are located within the same building. They share the same broadband network and use a bigger router for load balancing, security and VoIP features. So to keep all the companies separated but still share the same internet connection, we can create 4 VLANs in the network. Let's call them VLAN 5, VLAN 6, VLAN 7 and VLAN 8. Of course, in this case we want to keep interLAN routing disabled. These are just a couple of instances where VLANs can be very helpful. Another example where VLANs are used is in adding a VLAN tag for the WAN connection. This is set up in the WAN General Setup configuration menu in DreOS routers. And the reason for that is that some NBN service providers use VLAN tagging for WAN connections. When connecting a Dratec router to one of these service providers, you'll need to enable the VLAN tag on the WAN side. Otherwise, data connection won't be available. This comes up with some New Zealand ISPs as well. The table at the bottom shows service providers in New Zealand use a VLAN tag of 10. Most ISPs in Australia use a tag of 100, but there are a number of exceptions, so don't assume. Well, you're not going to hurt anything by trying the wrong one. If that doesn't work, then you'll need to search the ISP's website to find the right one. Here's a situation where that VLAN tag on the WAN can get a bit tricky. This example is for Vodafone in New Zealand, but it also comes up in Australia as well. The ISP supplied a router with phone services built into it. The problem arises if you need to replace that router with something with better features. While Dratec do have routers with built-in analog telephone adapters for phones, so we could technically just replace the ISP supplied router, the phone settings are usually locked to the ISP's router and they're reluctant to reveal what they are. So we're stuck using the ISP's router. No problem, we just plug their router behind the Dratec. We have a double NAT situation going on here, but there's only the phone plugged into the second router and it'll work fine just like that, except for one problem, that VLAN ID. For the phone to work, the ISP router needs to have that VLAN tag on its WAN port, and so does the Dratec router. That won't just pass through the Dratec router, so to make it work we need to enable that same VLAN ID on the Dratec router LAN port that the ISP's router is connected to. This screenshot shows the settings used. We have configured VLAN 1 on LAN port 4 as a tagged VLAN port with a VLAN ID of 10. All other ports and SSIDs are allocated to VLAN 0 with no VLAN tag. The ISP's router retains its VLAN tag of 10 on its WAN port, which is connected to LAN port 4 on the 2120 series router here, which also has a VLAN tag of 10 on its WAN port for the connection to the ISP. That keeps the phone online. Makes sense? If you want more detail on this procedure, we made a video a couple of years ago called Dratec Transitioning Phone Services to the NBN Part 2. I'll leave a link to that in the description below. Okay, let's get into the VLAN configuration steps in Dratec routers. We'll start with port-based VLANs. This applies to DreOS routers such as the Vigor 2865 and 2927 series, as well as others. The steps involved are also covered in our knowledge base articles on our website. Just go there and search for VLAN and you'll find a wealth of information. The first step is to go to the LAN VLAN configuration menu, then enable the VLAN configuration. The next step is to assign all ports and SSIDs to VLANs, then select a LAN subnet for each VLAN shown in the circle there. Note the number of ports and VLANs will vary by the router model. Also, for port-based VLANs, we don't enable VLAN tags. The next step is to enter the LAN subnet details for each LAN, including the DHCP details. You'll find this under LAN General Setup. Just click on the Details button for each LAN. You can see here we've used the subnet 192.168.1.1 for LAN 1, 192.168.2.1 for LAN 2, and 192.168.3.1 for LAN 3. That'll keep those LANs separate. But what do we do if we do want certain LANs to be able to access each other? That's where inter-LAN routing comes in. You'll find this a little further down the LAN General Setup page. All you do is tick the box at the intersection of the two LANs you wish to route between. For example, here we've enabled routing between LAN 2 and LAN 3. And that's it. For Linux-based routers such as the Vigor 3900 and Vigor 2960, the setup is different. The first step is to create the VLANs and then assign the LAN port as untagged. The next step is to configure the LAN subnets for each VLAN. In the example here, we've assigned the subnet 192.168.50.1 to VLAN 100. In Linux routers, we have a global option to enable inter-LAN routing. To do that, select Enable Inter-LAN Route in LAN General Setup under the Inter-LAN Route tab. With the Using Route Group feature, you can use groups to allow or block routing between VLANs. Firewall rules can also be used to control traffic flow between VLANs. Setting up 802.1q tag-based VLANs in DreOS routers is similar to the setting of port-based VLANs, but includes a couple more steps. The first step is to go to the LAN VLAN configuration menu and enable VLAN configuration. Then assign all ports and SSIDs to VLANs, and then select a LAN subnet for each VLAN. The extra step is to enable the VLAN tag and assign a VLAN ID. The priority setting is optional. 0, the default, is the lowest priority, and 7 is the highest. It's also recommended to select Permit Untagged Device in P1 to access the router in the red box down the bottom there. The reason for doing that is that usually we'll have a switch in between the router and the computer in this situation, and the switch handles the tagged data packet. But if for some reason you want to connect a computer directly to the router, you won't be able to access the management page, but you will be able to do that by enabling this option. The next step, the same as for port-based VLANs, is to enter the LAN subnet details for each LAN, including the DHCP details. Then, if you want to enable routing between any VLANs, simply tick the box at the intersection of the two LANs. For Linux-based routers, select the VLAN for the member to become a tagged VLAN. In the example shown here, we've selected LAN port 2 to become a member of VLAN 30. Next, for tag-based VLANs, we need to set up the 802.1q trunk port. In DreOS routers, select all the VLANs and assign them to the same LAN port. In the example here, we've assigned all the VLANs to P1, so port 1 will be our trunk port that we'll connect a cable into to run to the switch. To set up an 802.1q trunk port on Linux-based routers, much the same as DreOS routers, we need to add all the tagged VLANs to the same LAN port. In the example shown here, we've added all VLAN IDs, that is 10, 100, 123, 20 and 30, to LAN port 2. Now LAN port 2 is configured as the 802.1q trunk port. This diagram is a typical application of VLANs utilising the 802.1q trunk. The switch is connected to the router with a single cable, and we connect the PCs to the switch LAN ports, and each department is assigned to a VLAN. Another example of a VLAN trunk is between a Dratec router and access point. Tagged VLANs from the router are sent over a single cable to the AP, then each SSID is assigned to one of those VLANs. Wireless users will be assigned to a VLAN depending on which SSID they connect to. Of course, each user will only have the password to the SSID that we want them to use. We made a video a little while ago about how to set this up, and I'll leave a link to it in the description below. Okay, so in this session we learned that VLANs help in improving network performance by reducing congestion, enhancing security and adding flexibility. They allow a logical grouping of users by function rather than location, and they make it easier to administer networks. Dratec routers and switches support port-based and tag-based VLANs. Most but not all Dratec APs also support VLAN tags on SSIDs, which you'll see if you check out that video I just mentioned. Dratec routers support VLAN tagging on WAN interfaces as well, which is something often required by NBN ISPs in Australia, as well as some New Zealand ISPs. Something we didn't get into, which Dratec routers also support, is virtual WANs. This allows simulating several WAN connections through one physical WAN connection, which is often used for triple play services in some countries. Okay, that's all for now, but please stay tuned. If you have any questions, we'll be available in the live chat on the right of your screen for the next 5 minutes. For more information about Dratec products, please check out our website at www.dratec.com.au, or send us an email to sales@dratec.com.au, or give us a call on 02 9838 8899. Please like and subscribe below, and if you'd like a notification anytime we put up a new video, please select all from the subscribe drop-down menu as well. Thanks, and bye for now.